Hello everyone, welcome to my YouTube channel called Siliconvlsi. Today we will discuss about how to solve antenna effect in VLSI. So before moving to that, I just want to explain what is the antenna effect in VLSI. So let's start. The antenna effect, also known as the plasma induced damage, occur during the manufacture process of VLSI. It's happen when long metal interconnect act like antenna, collecting charge during the plasma etching, which can damage the gate oxide of the transistor. So here I just want to give you brief explanation about what is the antenna or what is the antenna ratio. If you draw antenna ratio, metal area upon gate area. So this ratio should not be greater than some number. This number, it depends on the technology. It will be vary with according to technology. So we just want to understand this thing, how this ratio is affect to transistor. So first thing, to avoid the antenna effect, our first movement will be, we need to place device as close as possible. Our main aim is to reduce the metal area. So let's assume this gate and this gate are connected. So we should put this two devices as close as possible so that we can reduce the metal area. So this is the first step to avoid the antenna effect. You should place as close as possible the devices which is connected to each other. So this is the first step. Second step is use metal jumper. So if device is not possible to place near to each other, second step is use metal jumper. So let's assume we are getting antenna error in metal 2. So we should always go for a higher metal. So let's assume this is metal 2. So we should jump for metal 3, not metal 1. If you know already why metal not, it is okay. If you don't know, just do comment. I will give you reply in the comment. So do you think, friend, this metal 3, like the cut which I did here in this region, it is okay? No, this is not okay. We should cut the metal to near to the, let's assume from here, like I cannot say this is the gate. It could be a drain. Two gate is not like here, should not connect. Like this is the drain, and the drain signal is going to gate. So better practice is we should always cut M2 or wherever we are getting the antenna. We should cut near to the gate only. We should reduce this area as much as possible. We should not cut here. We should cut it from here, like this way. So this is M3, M2, M2. So this is the best practice. So interviewer maybe ask you how you will choose cut, like from where you will jump, which location. That is very important here. You should always tell them like I should cut it from here, not from in this location. Put jumper near to the gate. In conclusion, we should always take care. We should cut the metal wherever we are getting antenna. We should cut near to the gate area, gate region only. So this is right, this is wrong. So second thing is this metal jumper. We should use metal jumper. If metal jumper is not possible, the design is fully congested, we cannot place the device near to each other. Third step will be antenna diode. This is the very important thing to solve the antenna error. Let's assume this is the gate and this is the drain. So if we are not going, like we cannot jump towards the top side and we cannot place near to each other, we should put antenna diode in this location, and that diode should always reverse bias. That is a very important thing. We should put that diode near to the device only, where gate is present. We should not put here the diode. This is wrong location. We should always put antenna diode near to the gate where we are getting the antenna effect error. Now second one, another thing, very important thing is how this diode will work. Do you know, friends, how this diode will work? So during this diode will active only during the fabrication process. Very high, so this diode will work as a resistor. So whatever current will be there, it will choose this path and it will discharge. In normal condition, like in circuit condition, this diode will always work as a reverse bias because of the lower temperature. So this is a very important thing. Here one question will rise, how this diode will work. So you have to tell, like during the fabrication process, this diode, because of the high temperature, this diode will work as a resistor. So this is very important thing. Now, so we have now the last method is use dummy fill. You can also use dummy fill to balance the charge distribution and minimize the charge accumulation on the specific metal line. Now I will tell you one question, so you should give me the answer. So if you don't know, just if you know, you just do comment, or don't know, you also do comment. I will let you know the answer. This is very important question. So interviewer asks you, I'm getting error in this antenna error in via 7. I will draw the cross section. So this is via 7. So obviously if this is via 7, then this will be metal 7, and on the top of metal 8 will be also there. This is metal 8. So interviewer is saying, like, I'm getting antenna error in via 7. How? Like they will ask you, why not in M7 and M8? Why I'm getting only antenna error in via 7? Because if you think, like if you see the antenna ratio formula, metal area upon gate area, or via area upon gate area. So but if you see here, the via area is very less as compared to metal 7 or metal 8, because always via is under either metal 7 or metal 8. Then why I am getting antenna area in via 7 only? Why not M8 or M7? So if you know the answer, please let us know. This is very interesting question. And so nowadays people are asking this question so many in company. So that's all, my friend. If you have any question, just let us know. Thank you.